Hello everyone, welcome back to my channel. My name is Lian Duan, and I have developed for 20 years, specializing in DevOps and cloud security. Today I'll do two hands-on demos, creating an AWS S3 backend with Terraform and using the AWS S3 backend in other Terraform projects. What is Terraform AWS S3 backend? Terraform AWS S3 backend is a cloud backend used to store Terraform state files. Without backend configuration, Terraform will use a local backend. The main differences between local and cloud backends are: local backend stores state files locally on the machine, where Terraform is installed and run. Local backend is suitable for individual or small projects managed by a single user. Cloud backend stores a state file in a remote cloud storage service, such as Amazon S3, Azure Blob Storage, or Google Cloud Storage. It's good for large projects and multiple team environments. Supports concurrent access from multiple users. Cloud backend provides advanced features like state file locking to prevent concurrent modifications, versioning to check the changes over time, and access control for security management. In this video, we'll focus on Amazon S3 Cloud Backend. In the S3 backend, the Terraform.tf state file saved to kernel version in S3. Also, the Terraform.tf state.backup stored to the previous version in S3. That means S3 versioning have to be enabled. Let's move on to hands-on demos. Before we begin, make sure you have Terraform installed on your dev box. If not, check out my videos on Windows 11 and Linux installations. Next, properly configure the AWS command line interface with an admin user. Also, my Terraform AWS provider's version is 5.8.0. Now we dive into first hands-on demo, creating a Terraform AWS S3 backend. In this demo, we'll create an AWS S3 backend, which requires two major AWS resources, DynamoDB and S3 bucket. Open the main.tl file, which one under the AWS S3 backend. Close the navigation, give more space on the main.tl file. Move down to resource part. The AWS S3 bucket resource creates an S3 bucket with optional settings like focus destroy and provide destroy for the developed environment. The two optionals allow Terraform destroy S3 even the S3 has content. Please remove them in your production environment to keep more safe. In line 44, versioning is enabled. That allows S3 to store Terraform.tf state.backup file in previous version. Move to next two resources for S3. AWS S3 bucket ownership is bucket owner preferred, and AWS S3 bucket ACL is private. The two items allow S3 bucket creating user fully control and access the bucket. Go down to the DynamoDB table. The resource defines the table to log Terraform process, providing concurrency issue. The primary key is log ID. The data type is string. Open my command window in the main.tl file folder. Move this bigger. Run command Terraform apply to create the resource. Here go through the resource. All looks good. Enter yes to create. Creating complete. Log into the AWS website to check the result. Go to the S3 service to verify the result. This is my result, demo bucket lien. You see the empty S3 since there no one uses it. Back to my markdown file. Next demo is creating a VPC with the AWS S3 backend. The VPC only includes one VPC and two public subnet. We'll integrate the AWS S3 backend into a VPC creation. Simply copy the freelance code. Open the VPC main.tl file. Paste the backend S3 content in the Terraform code block. Open a new command window under the AWS VPC path. On Terraform, you need a command first. Under the key name, demo01. Next, run apply command to create a resource. Yes, the resource created successfully. Open the S3 bucket, check the content, refresh the page. Open the demo01, go to versionings. You'll see this current version. If you want to see the content, please use the download function. Next, change the setter block to see the versioning workings. Let me change the setter block is in the public subnet 2. Run Terraform apply command to verify S3 versioning working correctly. We should see the 2 versioning files in the S3 bucket, creating successfully. Remember the previous version ID. We see there are 2 versions. This allows us to roll back a previous version if needed. That's all for today's video. Thank you for watching and see you in the next time.